it helped you to remember it. Okay, now about the detection of DNA or RNA, the detection. So how can it detect whether my sample contains any DNA or RNA, or sample contains any nucleic acid, for better instinct? So how can you determine that? As a consequence of this conjugated double bond system, as we have seen in this all cases, in case of this keto, and in this conjugated double bond system means this is the double bond system with N and C. So these double bonds are called the conjugated double bonds, and as this conjugated double bond presents there in purine and pyrimidine rings, the bases and all of their derivatives, which you can see, the derivatives of bases means the nucleosides, nucleotides, and nucleic acids, and all these things can absorb the highly strong light, or the near ultraviolet region of the light. That means they can absorb that light. So the absorption can be measured in 260 nanometer, as you all know. If I'm not wrong, I'm not sure about that, but it is 260 nanometer, I think. 260 nanometer wavelength. We can see the peak if we do a if we go through spectrophotometry analysis. We can see a peak in 260 nanometer if the sample contains any nucleic acid derivatives like nucleosides, nucleotides, and all this. Okay, the strong absorbance is often used for quantitative estimation, because if we estimate the presence of protein in such cases, sometimes the extraction of protein is not only purified in such a way that this protein can have contaminations of DNA. So in those cases, this principle allows us to identify whether my sample contains any trace of DNA or not.